the talk we're going to be going about is shifting left, how data contracts and Apache Iceberg can enable robust data lake houses. And so the way I like to kind of start is kind of like, what's my journey into this? Which button is it? There we go. So I joke around calling my data engineering villain arc. And I talked to a lot of other data scientists who became data engineers. It's a very similar story for them. I got hired as a data scientist at a startup to build all the cool ML things, do all the cool dashboards. And when I got there, complete mess of data. I couldn't even do my job. It was extremely hard to even answer simple questions. So being in the startup, I was like, you know what? I'm just going to fix that. I started building all the data infrastructure, implementing a data lakehouse, DBT, all that stuff. And they were like, hey, you should stay a data engineer. And that's how I ended up staying a data engineer. And turns out I loved it way more. But through this experience, I sat between the data science team and the software engineering team. And it kind of, these questions kept on popping up is, why is there such a huge disconnect between software engineers and data teams in respect to how data is used? I was told having all this data easily available to me in this data lake was a good thing, but that was just not matching my reality. I was pulling my hair out. And are the above just problems in my company, or is this like an industry problem? And after I talked to a lot of people, it turns out it's more so an industry problem that's happening. And then the next thing was, how do we fix this problem? And so Chad unfortunately couldn't be here. He had to do some other things for the business at Gable, but I was one of the first employees at Gable. And when he reached out to me and said, hey, I'm trying to solve this problem, I'm doing a startup, I quit my job the next day, put in my 2 weeks. And I was like, I want to work and fix this. So this presentation is going to be based on these two books. Apache Iceberg, which Alex is in the crowd somewhere. There you go. Definitely read the book. It's a really good read. And then also, Chad and I are writing a book with O'Reilly on data contracts. Early release is coming soon, but I got permission from my publisher to share some early snippets. And so the way I joke around about this is I call it the data prisoner's dilemma and the rise of the modern data stack. And so, you know, I talked to a lot of people who are in the kind of 2012s, 2015s, where some executives said, we need data science now. And they read that HBR article. And I think you'll know which one I'm talking about. Data science is the sexiest job of the 21st century. And so we kind of have these chapters of data, which I think other presenters have actually kind of noted as well. So formalization of databases, relational database, 80s, 90s, you had all that data modeling, good stuff happening. And then in the early 2000s and 2010s, that all got blown up. Big data became this big deal. Everyone wanted to do data science, and we had this rise of data lakes. And so the reason I call it a prisoner dilemma is that established tech companies validated the major competitive advantage that having big data was. So you have the Googles, the books, you're doing all those cool ML things, right? And in addition, the rise of cloud computing enabled cheap and quick adoption of data compared to previously on-prem implementation. So if you want to do a data warehouse, you had to go get this vendor, do all this big RFP thing process, this whole big mess, right? But it forced you to really think about your data because that's so much time into it. So as a company, this is where a prisoner's dilemma come in. Do you risk letting your competitor realize this advantage while you don't adopt data? Or do you risk implementing data where it could potentially not work, or you have this big outsized gain? And so this prisoner dilemma pushed companies towards quickly adopting data via the modern data stack. And so I call ELT jokingly, everybody looking tirelessly, because the modern data stack pushed companies into an ELT framework and by default, the data lake. And data lakes are not inherently bad. I think Santino really highlighted, like especially for ML, there's some really great use cases, but defaulting to them without considering the implications and the underlying business is. And that's actually one of my biggest takeaways from reading Joe and Matt's book, talking about how your data infrastructure choices need to be tied to the business use case, not just choosing the best practice, right? And so through this time, our data modeling just comes lost as massive amounts of data was dropped into data lakes with this experience to just figure out after the fact. Thus, we started seeing the rise of data swamps. Where at best, you couldn't find the data you need. It's like a needle in a haystack. At worst, you just gave the wrong data. And so then we had the rise of the data lakes, where you have this flexibility of the data lake and then the structure of a data warehouse. There's been multiple presentations today going into that, so I won't dive too far into that. But essentially, we have this kind of medallion architecture typically for these implementations. We have the bronze, raw data, silver, normalized, clean data, and then gold, established metrics and whatnot. But problems still persist. And so I argue that we're having an industry shift right now from moving from collecting just metadata, knowing what's in your data lake and whatnot, to actually automating and actioning this metadata. And so thinking about like Maps versus Google Maps. Map your metadata, you know where things are at, where you need to go. But Google Maps is pretty smart. If there's a traffic jam, it'll redirect you. If there's some issue happening on your path, you can choose different paths for it, right? And so a common question I get about data contracts, and I'll get more into what that is how does it differentiate from data catalogs? And data catalogs are a great starting point. I think they're very important. But now we're moving to we actually need to take action on this. But the problem is, if you're an enterprise company, taking action on just massive amounts of information is just really hard. Hence why we need to abstract it away and automate it. And so we see this emergence of data contracts and Apache Iceberg, where they're kind of solving the similar problem from opposite ends of the data lifecycle. And so, high level of Apache Iceberg, I argue, is managing metadata downstream for performant data lakehouses. Apache Iceberg consists of three main layers. And there was an image before that showed kind of what those layers are from the architecture perspective. But we have the data catalog, where data is all kind of stored where it's mapped out. We have the metadata layer, where various files enable Apache Iceberg to take action on the provided metadata. Bowling that's going to be important. And then the data layer, which is what we're all used to kind of dealing with the queries. And so one thing I really want to highlight is that the metadata layer is essential for efficiently managing large data assets and enabling core features such as that time travel piece. And I want to really dive into that time travel piece because I think that's how it really connects with data contracts. Also, quotes from the book, please read it, it's great. So information for a table's historical state is accessible, allowing you to run queries on the state of the table at a given point in time in the past, what's commonly known as time travel. And so switching lenses to the other side of the data lifecycle, we have our data contracts. And that image is an example of a contract spec, which is a YAML file. And so in respect to data lake houses, data contracts ensure the metadata, such as the schema, stays consistent throughout the data lifecycle upstream. And so the way you think about it is like that bronze data in your data lake house, ensuring that it stays consistent. Some change the engineers do upstream doesn't break something and you have all these dependencies all of a sudden going down. And so rather than reactively solving issues that surface due to upstream changes, the metadata is used to automate enforcement expectations, and this happens in the CI/CD process. And so from our book, this is a typical kind of schematic of how people organize their data. You have a transactional database, analytical database, all those things. A lot of the literature conversations really focus on this like replication from transactional analytical data for data contracts. But actually, you can put data contracts on all over the place. So that's extremely useful. But for the case of this, these are the main areas that I think are really helpful for data contracts in data lake houses. And so this is what the workflow looks like. You identify your constraints, you put that into a YAML file, and then your producer, such as engineers, agree to that. And now it's part of the CI/CD check. Hey, did you make a change to the underlying database? If so, is there a contract? And did you violate it? No? Great, keep on moving forward. If you did, then alert the data asset owners who are going to be impacted, and then have fail tiering. Hard failure, hey, it's an ML model that charges, makes $1 million a month. You want to make sure that doesn't break. Maybe it's a software, you just want the data to go through. And that software is where I think really data contracts and Apache Iceberg can be really useful. And so real quick, just kind of make it real beyond theory. This is what this looks like in our product at Gable. When someone breaks a contract, this is the context they get in the CI/CD workflow and in GitHub. And so how can it integrate with Apache Iceberg? Well, in this workflow, you read the metadata stored by Apache Iceberg and documents available data assets. Data consumers identify what constraints are important for their workflows and places a data contract. And then the validation of contract. You stop the change from even happening, which is very restrictive. And when I talk to many data teams, they don't have the relationship with engineering teams to actually do that. And so another option they have is it just alerts the stakeholders, but doesn't stop the change. It's less restrictive, but easier for data teams to implement. And where I argue that Apache Iceberg can really work well with this is that when that happens, you can trigger Apache Iceberg to utilize this time travel feature and roll back. And so you're alerted of these breaking changes, but you're not impacted. And so when I was a data scientist, we had these batch jobs and engineering broke something. I have to wait a whole week before I do my analysis. I see someone shaking their head. They feel the pain. And you know, how can we avoid that? How can I not lose a week of my work if engineering decided to solve it really quickly? And so some closing thoughts. Data entry is moving from collecting, understanding metadata to now actioning metadata via abstracted automations. Two emerging ways it's happening is Apache Iceberg and data contracts. Both are solving a similar problem, but from opposite ends of the data lifecycle. And together, through the CI/CD process, you can actually trigger, hey, something's about to break. There's some important changes. Why don't we protect that database, do some rollbacks to time travel features for that? And so that's in the presentation. You can learn more about what we're doing at Gable.ai, or I scream into the void of LinkedIn all the time. And so if you want to see that, you can follow me there. I talk about data contracts a lot there.